In this video, I am going to explain you the concept of how XLAT instruction will be executed. So basically, this instruction will be used for translating our user table information and into our register structure. So this instruction will replace a byte in the AL register with the byte from the memory. It is also used for exchanging the byte of data that is given in the AL register from the user table index to the table entry. So this is the user table index is given, that is from address 1000H location to 1009 location. This is called as a lookup table. So I'm writing here lookup table, and this lookup table consists of information of our address of particular data. So in this XLAT instruction, we will transfer the 16 bit of our information at a time. There are two versions of our XLAT instruction. First of all, the instruction is XLAT, that is XLAT. Whenever we don't have the operands in our XLAT instruction, that time we are using the second version of our XLAT instruction, that is XLAT B instruction. So what are the operations will be performed in our XLAT instruction? Our data will be stored into our AL register. But how it will be stored in our AL register? It is our data segment, and they are taking the data from the data segment. Then they are adding the BX plus AL register together, and whatever the contents will be there, that are copied into our AL register. Now we will see how this operation will be executed in detailed manner. So in the given example, there are three statements are given, that is move bx comma offset table. So whenever we are writing here the offset directory, that time it will store the address of particular variable or particular memory location into our 16-bit register. So here we have write move bx comma offset table. So what is the starting location of our table? That is 1008. This is the starting location of our table. So I am transferring this table starting location address into our BX register. So BX is equal to 1008. So this is the memory location that is pointed by our BX register. Now the next instruction is move AL comma 00H. So AL is equal to 00H. So the contents of our AL is equal to 00. Now we are executing this XLAT instruction. So here we will see how this will store the data into our AL register and how our data will be modified into our contents of our AL register. So in the given table, there are locations from 1000 to 1009, and 1000 indicates that 0 dash, then 1001 indicates that 1 dash, and so on. So whenever we are storing here A, B, C, D, E, F and G, these bytes are stored like this. Suppose we want to store here the value that is 5, that time we are writing this 5 like this. So that time your A will be enable, your C will be enable, your D will be enable, F will be enable, and G is also enable. So these bytes will be enable, and our B and E byte will be disable. So here I am writing B and this is E. So these two bytes are disable. So I am writing here the table that is A, B, C, D, E, F and G. So these are the total 7 bytes will be there. So that I am adding here X byte to appending the 4th byte in our structure. So A is enabled, so I am writing here 1. B is enabled, so I am writing here 0. B is disabled, so I am writing here 0. C is enabled, so I am putting here 1. Then D is also enabled, so putting here 1. E is disabled, so I am writing here 0. F is enabled, so I am writing here 1. G is enabled, so I am writing here 1. And our X byte is not available, so I am putting here 0. So now we have put here from A to X register, and I am putting all the bytes as per this structure. So whenever you are pointing here 5, that time this structure will be available. And according to this structure, you have to put this byte like A, B, C, D, E, F, G, and the last one is X. So whenever you are considering this 4 upper nibble part and this is the lower nibble part, that time you got the answer 6 and 1101 is nothing but D. So your answer is 6DH. So whenever you are performing this XLAT instruction, so what this instruction can do? It is used for translating the lookup table information, and the data will be stored into our AL register. And how this will be stored? It will be pointed by data segment, and our value of BX plus AL will be combined together, and that data will be stored into our AL register. So this instruction will be used for translating our address of our lookup table information and store the data into our AL register. So now check here, whenever we have write here move bx comma offset table instruction, that time the value of our bx is equal to 1008. And our contents of our AL is equal to, we have considered 05H. Suppose we are taking first of all the value AL is equal to 00, and suppose later on we have added here move AL comma 05H. Now the contents of our AL becomes 5, and according to the 5 we have set here the bytes. So whenever you are adding here 1000 plus 05, that time you got here 1005 in our memory location, and this memory location is now pointed by our data segment, and that will be pointed and that will be stored in our data segment register. Now currently we are pointing to the 1000 location, and simply we are directly locating to the 1005 location, and in that 1005 location the value is stored 5 dash. And according to our this byte, we got the result that is 6DH. So whenever we are storing the value into our register, we can't store this value that is 5 dash. We will show this register as a value like 6DH. So this 6DH will be stored in our AL register. So here what we have done, this XLAT instruction is used for translating the address of our lookup table, and the data will be stored into our 16-bit AL register, that is in our accumulator register. So in this example, the value of our AL is 5, and we have added this 1000 plus our 5, then it will become 1005, and this data table will be located in our 1005 location, and in our 1005 location the value is stored that is 5 dash, and 5 dash is nothing but 6DH according to this structure. So we got here the table that is 0110 1101, that is nothing but 6DH. So our final result is AL is equal to 6DH. So here our XLAT instruction will be executed successfully, and after execution of our XLAT instruction, the contents of our AL is equal to 6DH. So in this way, the XLAT instruction will be executed.